For our topic today is Johannes Kepler. Short introduction, Johannes Kepler was a renowned German mathematician, astronomer, and astrologer who made scientific contribution to the field of astronomy. His work has had a profound impact on society and continues to influence science to this day.
So now, we will talk about what the scientific revolution is about. Occurring mainly throughout the European region during the 16th to 17th century period is what we currently term the scientific revolution, a substantive era of scientific and intellectual advancement. Mathematics, biology, astronomy, chemistry, and physics all gave way to fundamental transformative breakthroughs advancement that are considered as laying essential groundwork for present day modernized scientific exploration and discovery purposes. The influence of the scientific revolution on society, religion, and philosophy was immense. It brought forth alterations to entrenched beliefs by fostering skepticism and secularism. Moreover, it endorsed progress as an attainable idea with humans capable of apprehending and utilizing their environment for their benefit. Overall, this revolution distinguished a fundamental turning point in human history, leading towards the Enlightenment period advancement as well as groundbreaking strides into modern science like technology advances through industrial revolution. So what is the contribution of Johannes Kepler to the scientific revolution? The realm of celestial mechanics underwent significant transformation when Kepler launched an exciting era of discovery purely aided by basic arithmetic knowledge, leading him to unveil three fundamental laws related to planetary movement, primary among them hinting at how they progress through space operations, accurately describing their movement around our central star, causing resounding impact towards comprehending beyond Earth existence. Initially put forth by Keen's synchronity of data indicating no circular movement, but more elliptic ones creating what is now called Kepler's first law, relating to planetary orbit path shape configuration with stunning reality. Then fourth, developed second law demonstrating for closer proximity causing planets swifter movements compared to farther distances from body, providing albeit convincing conclusions than ever before, outlined before scientists today, prominently using it to explain phenomena. Finally, the third law of planetary motion describes a planet time to complete an orbit is proportional to its distance from the Sun, revealing crucial insights into our understanding of celestial mechanics. When considering advancing our comprehension of outer space, Kepler's work proved incontrovertibly significant given its reflection on empirical data usage and reliance on mathematical models within scientific inquiry. Foundational to underpinning one vital aspect of modern science, Newtonian physics, are his planetary motion laws that unquestionably allowed Isaac Newton to develop his revolutionary concept related to universal gravitational significance. Therefore, with Kepler laying fundamental basis for impending scientific revelations ensuing from his critical advan- advancements introduced during the scientific revolution, it proved an unending catalyst that magnified significant strides made by physics researchers further forward towards discovering new insights into the universe.
So, Johannes Kepler had connections and interactions with several key figures during the scientific revolution. This individual influenced his work and supported his research. First is Michael Maestlin. He was a German mathematician and astronomer who taught Kepler at the University of Tübingen. He was an early supporter of Copernican heliocentrism and influenced Kepler's interest in astronomy. Maestlin serves as Kepler's mentor and had a profound influence on his scientific development. He introduced Kepler to the works of Copernicus, taught him essential mathematical and observational skills, and shaped his approach to astronomy. Next is Emperor Rudolf II, the Holy Roman Emperor. He appointed Tycho Brahe as his imperial mathematician and provided Kepler with access to Brahe's extensive astronomical data. Kepler relied on Rudolf II's support to conduct his research and publish his groundbreaking works. Next. Next is Tycho Brahe. So at the age of 27, Kepler became the assistant of a wealthy astronomer, Tycho Brahe, who asked him to define the orbit of Mars. Brahe had collected a lifetime of astronomical observations, which, on his death, passed into Kepler's hands. Brahe's observations became the foundation for Kepler's law of planetary motion, which revolutionized our understanding of the solar system. And the next. Last is Galileo Galilei. They were not only contemporary, but they were fighting the same battle against the religious freedom at their places. Galileo and Kepler came into contact when Kepler sent his book, Mysterium Cosmographicum, to Galileo in 1597. In response to this gift, Galileo wrote a letter to Kepler. In the letter, Galileo praises Kepler for being one of the few individuals who believed and supported his statements about his astronomical observations. Although they did not meet personally, they support each other's discoveries and works. So these individuals collectively contributed to Kepler's scientific development and through their influence left an indelible mark on the understanding of the cosmos.
I will now move on to the controversies that Johannes Kepler's works and inventions caused. Johannes Kepler was an astronomer and mathematician who lived in the 1600s. He made significant contributions to our understanding of the universe. His new ideas and work came with debates and problems. Today, I will discuss 4 controversies of Kepler's works and his ideologies. Starting with the first conflict, which is Kepler's departure from traditional astronomy. One of the most controversial aspects of Kepler's research was his departure from conventional astronomy, which was greatly influenced by the geocentric paradigm. Kepler discussed his heliocentric theory, which positioned the sun at the center of the solar system, in his book Astronomia Nova. This was contrary to the widespread belief that the Earth was stationary in space and the center of the universe. Leaders in science and religion at the time battled vehemently against this notion. Next. His second controversy was his loss of planetary motion. Kepler's Harmonices Mundi, in which he discussed the principles of planetary motion, altered how people saw the motion of planets. But these regulations created a lot of controversy and went against widely held beliefs. The first rule, which said that planets travel on erratic courses rather as perfect spheres, defied conventional knowledge. Additionally, according to the second rule, sometimes known as the rule of equal areas, planets move more quickly the nearer they are to the sun. This goes against the notion that all planets all move similarly. Next, his work sparked discussions between astrology and astronomy. While Kepler himself was a skilled astrologer, he worked to set astronomy apart from the astrological traditions to distinguish it as a scientific field. The conflict between astrology's mystical interpretations and the scientific endeavor to comprehend celestial occurrences sparked debates and prompted inquiries regarding astrology's validity as a prediction tool. Last but not the least, conflict. Kepler's findings and scientific achievements significantly impacted the existing religious views at the time. Kepler unintentionally doubted biblical interpretations by contesting the geocentric worldview and giving evidence for a heliocentric system. Kepler's disagreements with religious leaders resulted from this conflict between scientific advancements and dogmatic beliefs. Some even referred to his work as blasphemous. In conclusion, to summarize his conflicts with the society, Johannes Kepler's works and inventions were not immune to controversies and issues. His departure from traditional astronomy, the introduction of his laws of planetary motion, the clash between astrology and astronomy, and the religious implications of his discoveries all sparked debates and resistance during his time. Despite these controversies, Kepler's contributions played a pivotal role in shaping our modern understanding of the universe, leaving an enduring legacy in astronomy and science.
German mathematician, astronomer, and astrologer Johannes Kepler made substantial contributions to the area of astronomy and was a key figure in the development of modern science and scientific thought throughout his lifetime. Here are some of his most significant contributions. First is the law of planetary motion. Kepler's most notable contribution was his formulation of the three laws of planetary provided a mathematical framework for understanding celestial mechanics.
Second is the Kepler supernova. In 1604, Kepler's observation and documented the appearance of supernova, known as Kepler supernova or SN 1604. His observation challenged the prevailing notion that celestial bodies were immutable and provided evidence for the idea that the universe is ever-changing. This discovery contributed to the development of modern astronomy and our understanding of stellar evolution.
Third is the astronomical instrumentation. Kepler developed innovative astronomical instruments to enhance observations. He improved the design of the refracting telescope and invented the Keplerian telescope, which used a convex lens as an eyepiece, resulting in clearer and more accurate images. Kepler's advancements in instrumentation improved the quality of astronomical observations and laid the foundation for future developments in telescope technology.
And lastly, optics. Kepler's work extended beyond astronomy into the field of optics. He invented the properties of light and vision, leading to his formulation of the laws of reflection. His research on optics contributed to the development of telescopes, microscopes, and other optical instruments that are vital in the modern scientific research.
So how did Johannes Kepler's inventions or works advance modern science and scientific thinking at the time? By questioning conventional assumptions and presenting new paradigms, Kepler's innovations and work profoundly expanded scientific thinking throughout his time. His equations of planetary motion gave a more precise and elegant account of celestial motion, paving the way for subsequent astronomical advances and the creation of Newtonian physics.
So in conclusion, Johannes Kepler's work has had a profound impact on society and science. His formulation of the laws of planetary motions, his observations of Kepler's supernova, his contributions to astronomical instruments, and his investigation in optics all contributed to his lasting legacy in advancing our understanding of the universe. Kepler's work continues to shape our scientific knowledge and inspire future generations of astronomers and scientists. And that's all. Thank you for listening.